Welcome. My name is Patricia Rios. I am the Director of Education and Advocacy and your host for today's webinar on working smarter to prevent bladder cancer, understanding how jobs and environment affect risk. Bladder cancer is a complex disease with many risk factors such as age, gender, and genetics. Exposure to harmful chemicals can also put people at risk. For example, people who smoke are 2 to 3 times as likely than non-smokers to be diagnosed with bladder cancer. Yet, many bladder cancer patients have never smoked. Scientists are learning that other kinds of toxic chemicals in our environment, meaning chemicals that we come in contact with where we live, work, and play, are important contributing factors that can increase a person's risk of developing bladder cancer. Based on growing body of evidence, more than a dozen chemicals and other industrial agents have been linked to bladder cancer alone. And to shed light on the connection between bladder cancer and the toxins in the workplace and our environment, we are joined by 2 phenomenal speakers, Dr. Stella Kutros from the National Cancer Institute and Dr. Sunil Patel from Johns Hopkins Medicine. I'm going to introduce our speakers and then hand over the screen to them for the presentation. So Dr. Kutros is a cancer epidemiologist in the Occupational and Environmental Epidemiology branch in the Division of Cancer Epidemiology and Genetics at NCI, or the National Cancer Institute. She is an internationally recognized expert in the design and the conduct of epidemiological studies to evaluate workplace exposures as risk factors for cancer and to clarify the causes of bladder cancer. Dr. Sunil Patel is an assistant professor of urology and oncology at the School of Medicine at Johns Hopkins. He serves as the director of the Urologic Oncology Fellowship. His clinical and research focus is obviously urologic oncology with areas of focus in bladder cancer, testis cancer, and kidney cancer. Dr. Patel joined the Johns Hopkins Medicine in June 2020 with interest in environmental factors contributing to oncogenesis or development of tumors in urological cancers, particularly bladder cancer. That was a short description of their very extensive background. And so we are honored to have them both here today so we can learn a little bit more about the connection. And so with that, I am going to go off camera and hand the screen to our first presenter, which is Dr. Patel. After Dr. Patel's presentation, you will hear from Dr. Kutros. So without further ado, Dr. Patel, the screen is all yours.
Over the last several years, and kind of going into some of the key studies and the study designs, as well as a little bit the data and the results on some key factors. So we're going to highlight some environmental risk factors for bladder cancer. We're going to look a little bit on the data on disinfecting byproducts, arsenic and nitrates, and look at some of the evidence that is pretty strong that we have for carcinogenesis for these environmental risk factors and some emerging and kind of uncertain links. And then really talk about the gaps in future research needs. Next slide, please. So as Patricia kind of highlighted, again, this is a very general slide, but smoking, again, is the leading cause, with smokers being 2 to 3 times more likely to develop bladder cancer. Environmental exposures. So we do know that working in certain industries like in the rubber, textile, leather, and or with dyes, whether that's hair dyes or aniline dyes or in clothing, does increase risk. And again, that includes both work and environmental. Secondhand smoke often gets misrepresented, but that is still another risk factor, as we know, for a lot of malignancies, bladder cancer included. Hydration is a very interesting one, and Dr. Kutros has done a lot of work in this as well. And we're going to highlight a study that kind of challenges this not drinking enough water and the fluid intake. But historically, it's been thought to that poor PO intake or fluid intake increases bladder cancer risk by concentrating carcinogens in the urine, which potentially can be, but there's some more data that may contradict that. And as we know, chronic bladder irritation can cause bladder cancer. Again, a little bit different type of bladder cancer. We usually see that in squamous cell carcinoma, so a little bit different than urothelial carcinoma of the bladder. However, that is still in the umbrella of bladder cancer. Next slide, please. So again, so smoking roughly attributes to around 50% of the bladder cancers. I know we highlighted this at the last year's think tank, but it's really what about the other 50%? As Patricia highlighted eloquently, that there are a lot of our patients in modern era that really aren't smoking cigarettes and they're developing bladder cancer. If we look at the historical trends, I believe around the 1940s and 50s, there's around 50% of at least the US population that smoked cigarettes or said that they did. If you look at the recent data in probably in the late 2000 teens and like 2020 or so, that number dropped down significantly down to anywhere from the 10 to 15% range. So there has been a significant drop in smoking, but we haven't seen that in the bladder cancer incidence rates. And so that begs the question again, what are the other factors? And so we do know from occupational studies, and again, Dr. Kucha is going to highlight this, that there are other risk factors, and this is really how we utilize our knowledge and how we learned about carcinogenesis in these other two areas, and how that can lay the platform and set the field for how to really study these environmental risk factors. Next slide, please. And so this was just a really nice kind of study that really looked at the case control, looking at men and women, and looked at just smoking and its attribution to bladder cancer. And if you look at two different cohorts, it's pretty consistent that smoking attributes to roughly around 50% of bladder cancer, both men and women. And so that has been really well studied. And these large case control studies, again, done by our expert epidemiologists, namely at the NCI, and a lot of colleagues of Dr. Kutros, as well as the law studies she's done, has really led to our knowledge of kind of population-wide studies on how these case controls can show what are the risk factors. Next slide, please. And that just tells you how many thousand patients were in each kind of cohort. So a very large case control study. Next slide. So let's shift over to arsenic. So arsenic is a naturally occurring metalloid. However, it's also highly toxic. It exists in an inorganic as well as an organic form. And arsenic has been one of those ones that have been studied for some time, and there is a strong association with bladder cancer. And we're going to kind of, over the next few minutes, we're going to highlight a little bit about the studies in arsenic and what we know about arsenic and potential mechanisms. Next slide. And so arsenic exposure is a little bit variable. So right now, when we really think about exposure, we're really attributing it to private wells. And so in the US, unregulated private wells are a major concern. For instance, in the northern New England, bladder cancer rates are much higher. We're going to highlight a key study, again, done by the NCI that showed this, but it's much higher than the national average, and it's largely attributed to arsenic in well water. Historical pesticides, which were really done in about probably 60, 70 years ago, were probably the biggest culprit. However, they're not really used in modern era, but they still have a lot of leaching into the ground and hence into our wells as well. And then dietary exposures. So certain foods, particularly rice, can absorb arsenic from the soil, especially the water as well. And a lot of that has been done, and we see that in a lot of our Asian cohorts, and that's been well studied, at least in Southeast Asia, as well as other areas of Asia. Next slide. Again, so arsenic has a pretty strong evidence there is strong evidence that inorganic arsenic increases bladder risk. Studies show that there is an increased risk with arsenic concentration in water as well. And we're going to highlight a little bit about time and dose-dependent variables. And the IARC classifies arsenic in drinking water as a known carcinogen. And again, a lot of this work was done, and a lot of these statements have really come out from the key study done in 2016 by the NIH NCI, linking bladder cancer rates and elevated bladder cancer incidence to the arsenic found in these private wells. Again, the New England study, New England water study, as we all call it. Next slide. And so this is a really nice figure that really highlights the incidence of bladder cancer and the mortality rates. And so if we're looking at the slide, this really looks at two key kind of time points. We're looking at Caucasian men and women, and looks at the two time points, 50 to 79, 1950 to 79, as well as the relative modern era, so the 80s to 2000s. And again, the striking thing you can see is the bladder cancer mortality rates are clearly higher in concentrated you see in the Northeast, much higher than you see all over the rest of the U.S. Also, Alaska's in there as well. But this really was a big launch pad for that big pivotal study. Next slide. And so this slide, or excuse me, this study was uh, led by Deborah Silverman over one of Dr. Koutros's colleagues. And they looked at the very comprehensive study. And Dr. Kouchos did talk about this study in detail at our think tank. But long story short is that this study was really well done, and it really looked at two key things. One is that really showing that the arsenic exposure in private wells in New England varied. However, the higher amount, there were higher incidence of bladder cancer. They did talk, and they really looked at also different differences in the well types and the shallow and deep. And we essentially found out that arsenic concentration was correlated to bladder cancer incidence. Additionally, again, when I earlier mentioned that the constant or the volume of water potentially altered incidence, and this study did show that there was a little bit of a increased incidence. So the higher volume or tap water that was drunk by these patients, or volume of water, excuse me, not tap water, will increase the incidence of bladder cancer. So challenged that dogma. Additionally, that we found that there's roughly a latency period around 40 years-ish from the exposure and this chronic exposure to the development of bladder cancer. So unfortunately, it's not one of those ones that if you drink well water once in your life, you're probably going to get bladder cancer. This is usually repetitive over a period of numerous years in order to develop bladder cancer. And interestingly, Dr. Kouchos actually did a follow-up study similar to this, but you can see that the arsenic exposure in carcinogenesis was almost augmented in smokers. So arsenic has never been thought to be a mutagen by itself, but almost in synergy with smokers, thought to be a kind of co-mutagen. And Dr. Kouchos, in one of her studies, found that it did increase the risk of bladder cancer. So arsenic exposure in combination with smoking did increase incidence. Next slide. And again, so talking about dosing. So when we talk about exposures and risk factors, we always think about what is the time needed in order for you to be exposed under X chemical or toxicant, and also at what dose. And I think that comes into play. And so what we found in this study that bladder cancer increases at higher levels of arsenic. And this study found it a little bit higher levels than what the NCI found. However, that low to moderate still is uncertain, but there's still studies that do show that it does increase the risk when you combine it with smoking, which Dr. Kouchos found, and other genetic factors. And again, the genetic factors, it's still an ever-changing kind of landscape right now. And that's what we're trying to learn a little bit more about. And again, sets the platform for how to really study these.